Welcome to my YouTube channel, a Brainery of Civil.
Today I am going to solve the fifth assignment of Strength of Materials. So here he has given a note information. Normally in the expression of hoop stress, longitudinal stress, R is the mean radius. However, for all computational purposes, internal diameter can be considered as R, because in thin pressure vessels, the internal and external diameter are almost similar. So, coming to first question. In a thin cylinder, the stress acting along the length of the cylinder is known as. So, in thin cylinders, there is two types of stress. One is acting along the length. That stress is called longitudinal stress. One is acting along the circumference. That stress is called circumferential stress or hoop stress. But he asked along the length. It is a longitudinal stress. Answer A for question number 1. A thin cylinder having internal radius R and thickness T is subjected to an internal pressure P if the change in internal radius due to pressure is X. Then internal circumferential strain would be. So obviously strain is equal to change in length divided by original length. Here change in radius divided by original radius. So change in radius he has given, it is X, and original radius is R. X by R is the answer. Answer A for question number 2. Coming to third question. A cylindrical steel pressure vessel 1250 mm internal diameter with a wall thickness. So he has given 1250 internal diameter and wall thickness T is equal to 25 mm and P is 10 MPa. Calculate circumferential stress and longitudinal stress. So circumferential stress sigma x is equal to PD by 2T. So 10, D is 1250 divided by 2 into 25. So that is equal to 250 MPa. And longitudinal stress sigma y is equal to PD by 4T. So P is 10, D is 1250 divided by 4 into T is 25. So that is equal to 125 MPa. Okay, so the answer 250 and 125. Answer A for question number 3. Now, a thin cylindrical pressure vessel is subjected to an internal hydrostatic pressure. Determine the ratio of hoop strain and longitudinal strain. First of all, we have equations sigma h, hoop stress is equal to PD by 2T. Sigma longitudinal stress, sigma L is equal to PD by 4T. Clear? Now, first we will calculate hoop strain. Hoop strain epsilon h is equal to delta D divided by D, that is change in diameter divided by original diameter. That is equal to sigma h minus 1 by m sigma L divided by E. So, by substituting this PD by 2T and PD by 4T in that, we will get hoop strain is equal to PD by 4TE 2 minus 1 by m. This is expression for hoop strain. And then we will calculate longitudinal strain. Longitudinal strain epsilon L is equal to change in length divided by original length. That is equal to sigma L minus 1 by m sigma h by E. So if you will get the values of sigma L and sigma h, you will get epsilon L as PD by 4TE 1 minus 2 by m. So now he asked us to calculate epsilon h divided by epsilon L. PD by 4TE and PD by 4TE, it will get cancelled. 2 minus 1 by m, that is equal to 1 minus 2 by m. So you will get it is 2m minus 1 divided by m minus 2. So the answer is C for question number 4. Next question. A cylindrical pressure vessel having internal diameter 500 mm and contains air pressure 10 MPa. The maximum permissible circumferential stress in the vessel must not exceed 100 MPa. The thickness of the vessel is. So coming to, he has given diameter D is equal to 500 mm and pressure B is equal to 10 MPa. Sigma hoop stress permissible is equal to 100 MPa. So now the permissible circumferential stress in the vessel must not exceed. So we need to calculate thickness. We have expression sigma h is equal to PD by 2T. So sigma h value is 100 and P is 10 and D is 500. 2 into T. So where T is equal to 25 mm. Okay. So the answer is C for question number 5. Coming to question number 6. So this is a case of spherical shell. It is not cylindrical shell. So a spherical shell pressure vessel having internal diameter D is equal to 500 mm and wall thickness T is equal to 20 mm. Coated with a brittle lacquer that cracks when strain exceeds. So throughout the volume there is some strain. He has given it is a volumetric strain is equal to 3 into 10 power minus 4. So what internal pressure? So P we need to calculate. Okay. So now we have epsilon V is equal to 3 PD 4 TE 1 minus mu. So where epsilon V is equal to 3 into 10 power minus 4. 3 and P is equal to, we need to calculate, and diameter D is equal to 500 mm, 4, T is 20, E is equal to 2 into 10 power 5 minus 1 minus 0.3. So that P is equal to 4.57 MPa. So the answer D for question number 6. Now coming to a cylindrical tank having 2.5 meter internal diameter, that is 2500 meter, and thickness is given as 25 mm and internal pressure P is subjected to 80 MPa. So the maximum permissible gas pressure is equal to, clear? So that is sigma h. So this maximum is 80. So first of all we will take sigma h as 80, in that PD by 2T. So if you will calculate this, P is how much? And D is 2500 and 2, T is 25. If we will calculate P is equal to, here it is 1.6 MPa. And if we will take the maximum value as longitudinal stress, so it will be PD by 40 is 80 P 2500 425. So you will get P is equal to 3.2 MPa. So that is, if we apply a pressure 1.6 MPa, it will be safe against hoop stress. If we will apply 3.6 MPa, 3.2 MPa, it will be safe in longitudinal stress. So that is, out of these two, whichever is minimum pressure that we have to apply, so that the cylinder has to be safe against both longitudinal as well as circumferential. So the answer is 1.6. 7 answer is B. Coming to question number 8. So he has given much information, but what the data we require? D is equal to 2000 mm and temperature T thickness is equal to 20 mm and pressure P is equal to 2 MPa that he has applied. Delta T decrease is 75 degrees centigrade. So what are all the stresses due to pressure? We need to calculate. Stresses due to temperature we need to calculate. First, stress due to pressure, hoop stress, PD by 2T. This is tensile stress. P is equal to 2 into D is 2000, 2 into 20. So it will be 100. Because of temperature, stress is equal to E alpha T. E is equal to 2 into 10 power 5. Alpha is equal to 11.7 into 10 power minus 6. T is equal to 75. It will be 175.5. So this is compressive. This is tensile. So delta sigma, that is net stress applied, is 75.5. Approximately it is option D for question number 8. Now coming to question number 9. He has given length L is equal to 3000 mm and thickness T is equal to 10 mm and diameter D is equal to 300 mm and pressure P is equal to 3 MPa. So modulus of elasticity 2 into 10 power 5 mu is equal to 0.3. So he asked us to change in volume. So that is epsilon V, that is volumetric strain, is equal to change in volume divided by original volume. That we have a formula PD by 4 TE 5 minus 4 mu. Okay. So we need to calculate delta V. We need to calculate what is volume? Area, that is area into length. P 3, D is 300, 4, 10, 2 into 10 power 5, 5 minus 4 into 0.3. So by this you will get delta V is equal to 90654.58 mm cube. Okay. So this is a change in volume. And next, coming to a cylinder with a wall thickness T is equal to 20 mm. Filled with a fluid atmospheric pressure. The cylinder has an internal diameter D is equal to 200 mm and length L is equal to 1000 meters. If 20,000 mm cube of fluid is additionally pumped into the cylinder, find the hoop stress. That is, whenever we supply 20,000 mm cube, it will be the change in volume. So that is epsilon V is equal to PD by 4 TE 5 minus 4 mu. That is equal to change in volume divided by original volume. So change in volume 20,000. Original volume is pi by 4 200 square into 1000. So pressure we need to calculate. Diameter D is equal to 200. 4 T is equal to 20. 2 into 10 power 5. 5 minus 4 into 0.3. So by this we will get P is equal to 13.40 MPa. So option C for question number 10. Okay. So now coming to question number 11. A thin cylinder having diameter D is equal to 200 mm and internal pressure P is equal to 2 MPa. If the thickness is 10 mm, maximum shear stress we need to calculate. So before calculating maximum shear stress, what is maximum shear stress? It is a difference of major and minor principal stress divided by 2. So first of all, major principal stress is hoop stress. Sigma H is equal to PD by 2T. So by substituting the values, you will get it is 10. Sigma L is equal to PD by 4T. You will get it is 10. So tau max is equal to sigma H minus sigma L divided by 2. 20 minus 10 divided by 2, it is 5 MPa. So the answer is A for question number 11. And coming to last question. So a 6 meters long. So length L he has given cylindrical pressure vessel with hemispherical ends. Very important. Here both cylinder and spherical formula plays main important role. Finally, what he has asked to calculate change in overall length. So the length increased along with the spherical end, the diameter is also increases. Okay, so now first of all, longitudinal strain delta L divided by L is equal to PD by 4 TE 1 minus 2 mu. This is for cylinder. Here we need to calculate delta L is equal to P is 10 and 400 is length. You can observe here the outer diameter is 500 and thickness is 20 mm. So outer diameter minus 2 into thickness will give you internal diameter. That internal diameter is equal to 500 minus 2 into 20. So it will be 460. So this is D is 460. 4T is 20. E is equal to 2 into 10 power 5. 1 minus 2 into 0.3. So that will be delta L into L we need to do. It is 6000. Delta L we will get it is 0.69. So when we consider the longitudinal strain, change in length we got it is 0.69. And whenever the ends are spherical ends, it is come under spherical shell. We need to calculate change in diameter as well. So that is change in diameter divided by original diameter is equal to PD by 4TE 1 minus mu. So here P is 10, D is 460, 4T is 20, 2 into 10 power 5, 1 minus mu is 0.3. If we will multiply into diameter how much it is? it is 460. So you will get delta D is equal to 0.0925. If you will sum this, change in overall length delta L is equal to change in length divided by change in length plus change in diameter. 0.69 plus 0.0925, it will be 0.78. So the answer is option B for question number B. So now what I want to say finally is, whenever it is required to face NPTEL exam, you need to practice each and every question in all the assignments. Okay, so all the assignment links are there in the description. So you can complete all the assignments and you revise again. Many questions will be repeated in the final exam. Clear? I hope you will do that. All the best for your NPTEL exam. Thank you.